Welcome to my new calculus channel. My name is John Gabriel. Today I'd like to address some of the hypocrisy that I've encountered. I have discussed some of these topics in previous videos, but what really strikes me as quite peculiar and quite odd is that no matter how much evidence one provides to the mainstream academics, they refuse to admit they're wrong, and they continue to insist that what they believe in is correct. So this is a terrible thing in modern academia, and unless it's fixed, I'm afraid that the Church of Academia is simply going to face a similar fate to that of the Catholic Church. So let me begin with what I wanted to discuss with you today. In the debate that I had with the graduate from MIT, whose name is Anders Kaysork, he made a claim here, as you see in the screen here. I didn't need to make an intuitive guess. I don't know why this moved across like that. Oh dear. No, I didn't want to do that. Okay, let me see what's happening. Alright, so back to where we were. I didn't need to make an intuitive guess that 3x squared is the right answer as a derivative for x cubed. I just simplified for any h is not equal to 0. So he simplified and he got this. But how can he ever have made the intuitive guess that it's the right answer? There's only one way he could have done that, by setting h equals to 0, okay? So let's look at this a little more closely. I'm going to try and draw on the screen now. So what you have over here is this. Black color here. So you have f dash of x is equal to 3x squared plus 3x h plus h squared. Now, as I showed you in a previous video, f of xh is actually equal to the finite difference quotient, which you see me writing right over there. Yes, so this is f of xh. To get f prime of x, we have to do this. Yes? How else will you get it? If you don't do this and then set this expression here to 0, you'll never get 3x squared. Okay? So it's imperative, because there is no other way to find the value of the derivative. But Kaysork continues to say further down that there's no problem with just guessing it and then verifying that it's a right guess. Well, my continual problem with this is that there is no rigorous and sound way of finding the derivative in your bogus mainstream calculus. That's what I've been telling you all this time. In other words, yeah, sure, you can guess this, but do you have a rigorous way of finding it? No, you don't. And it didn't help for academics of the last 200 or 300 years, actually the last 150 years more than likely, to add a lim h equals to 0 of f of x h like that. This doesn't solve the problem, because you still end up with this expression over here, and this here is not the derivative. Okay, this here is in fact equal to f x h like that. Okay, to get the derivative, you literally have to set h equal to 0. There's no other way for you to get it. And if you set h is equal to 0, you're actually ending up with a 0, 0 quotient, which is meaningless garbage. Okay, so there's no way for you to set h is equal to 0, and yet without setting h is equal to 0, you can't have the derivative. All right, so that's what I wanted to show you. Now, if we look at the next statement he makes, it says, however, if you look at my argument carefully, you'll need to observe that it is neither 1 or 2. I didn't need to make an intuitive guess that that is the right answer. So he actually contradicted the previous statement. He says, let's go back to, I think this is 1. Go back to 1. Nope. Okay. And then it says, in 2, I didn't need to make an intuitive guess that 3x squared is the right answer in order to come up with that argument. Actually, it is a guess, because the method involved in getting it is nonsense. It's anti-mathematical nonsense. And this is what I was trying to point out to him. And then finally, in the last paragraph, he says, why can't you understand the difference between assuming that f prime of x is equal to 3x squared as a fact? Wow. You know, this is just unbelievable. There are so many things wrong with these two paragraphs, and I've already discussed it in the previous video, so I'm not going to go over it again. But as a guess to be treated with extreme suspicion and then checked using the definition, well, what he meant is, it's not really a definition, it's a verifinition. What he meant is this garbage here that you see in front of you here, checking it with this. But in order to check it with this, you still need to know L, which is the derivative. Do you understand that? How can you be such morons? Isn't it time that the lot of you put aside your pride and admitted you're wrong? There is only one way to realize new knowledge, and that is to admit you're wrong. That's 80% of the effort. Once you admit you're wrong, then you'll be able to sit back and examine the facts with an open mind. Because the more you persist on being correct, which you're not, the more unlikely it is that you'll ever be able to understand these facts and arrive at a knowledge of the truth. So I, the great John Gabriel, have given you a lot of evidence which you simply brushed aside and continued to ignore. And students are laughing at you. Do you realize that? There are many students who send me emails and tell me what ridiculous morons they think you are. Are you a lecturer of mathematics? You need to pay attention to what I'm telling you. Because you're just making a fool of yourself, and your grandchildren and your great-grandchildren will one day read what you've been teaching, and they'll laugh so heartily that if you were alive, you'd be ashamed of yourselves. So I wanted to just go over this again one more time, and I think I've actually explained this so many times that by now a lot of academics know it, but nobody is willing to come forward and say they're wrong and to change to the new calculus, which is the first and only rigorous formulation of calculus in human history. With that, I leave you for this video and hope to see you again next time in another video, hopefully talking about another interesting topic. My name is John Gabriel, and this is the New Calculus channel. Goodbye.